we were trying to talk about is basically the the model GPT and GPT-2. So GPT is basically generative pre-training, which is basically the building block of essentially the current chat GPT model which is out there. So it's also based on the concept of multitask learning, right? So chat GPT, as we know, is multimodal in nature in the sense that you can use the same model to perform different types of tasks, right? So in this particular case, the way the model has been designed is basically designed to predict an output based upon both input and the task at the hand. Right? And this conditional probability is basically what we cover in meta learning and multitask learning settings. So what we tend to do in this particular trick, like we have discussed in T5 previously, is that the language itself will define what to do in the prompt, right? So when we type it, we define in the language itself that what we wish to achieve in that particular scenario. And depending on that, the model will then help you in achieving that specific task easily. So for example, if you want to translate a sentence, so while translating itself, you can write that translate a particular French sentence to English text or French text or whatever, right? So when translate to French text, whatever, right? So in this particular case, you will specify during the task assignment itself that what you wish to achieve when you try to solve that particular task. Or
So is
in
it
case of,
like is
sorry,
it like prompt what was there in the previous slide? What exactly is a prompt here?
prompt means what you wish to do. Like so in GPT, when you ask the model to achieve, let's say you want the model to write an essay. So you will basically ask the model to write a comprehension on a specific topic. So there you are asking the model to generate text based upon an input, right? So you will give the model an input and the model will start generating the text on that input. If you ask the model translate a sentence to French, so then you are asking it to translate. So the prompt is basically what you ask the model to do. In the prompt itself, you will define what task you want to achieve.
So is it the same prompt which is generally getting discussed that we're supposed to learn prompt engineering or
Exactly. So how you engineer a prompt, that is how you define what you want to do for the model, because the model itself is designed to achieve different tasks. So your prompt should clearly define what you want to solve for that specific task. Yeah, correct.
there is nothing called as self-prompting like self-attention? Maybe I'm overthinking.
No. See, if you give a particular sentence to a model, the model will not be able to understand what you wish to do with that, right? So you can go to ChatGPT and you can type a sentence, but eventually the model needs to understand what you want to do with that sentence. So do you want to write an essay on it, or sometimes you communicate in a way that you convey what you want to do. But a lot of time it's not possible. So you need to be clear about what, otherwise the output will be incorrect, right? So if you want the correct output, the prompt should contain what you want to do. It's not like there is a syntax to it. So there is no structure that you have to follow, but your prompt should contain what you want to do, right? So if you want to, let's say you want ChatGPT's help to write a particular essay, or you want its help to explain you a particular topic. So there then you will basically say, okay, can you explain me what the meaning of mass language model is? So in that case, it will take mass language model as the word, and then it will explain, or it will write a comprehension on mass language model, which will allow you to understand the topic of mass language model. So your prompt should define what you want to do is basically what it's trying to say.
Okay.
And we know that a lot of times what happens is that it's pretty hard to get data for each task in a supervised way, right? So getting data for each task in a supervised way is not always possible. But what happens is that in on a web scale data, a lot of times you have data in a way which is already multitask in nature. So if you take a look at this comprehension, I'm not sure if it's properly visible or not, but this particular text already contains some piece of text in English and a translated version of it in French also. So that is basically scrapped from a particular website which contains text both in English and French. So automatically you have data available in English and the translated version of it available in French. So a lot of times you have that data available, so which you can readily use for performing multitask learning by language models. So that is called unsupervised multitask learning by language models. In which case you basically feed raw data to the model itself, and depending upon how the data is arranged inside the document that you're training on, the model will decode the task for you and then perform the task on itself, right? When that is called unsupervised multitask learning by language models. So I'll not go into the details there, but that is available as an option, which is in case you do not have enough data available, which is labeled, you do not have supervised data available, then you can go for this approach in which the training data itself will define, the prompts itself are available in the training data, and the model will then basically use that to perform the task at hand that you want to achieve. So talking about the challenges with generative models now. So the first biggest challenge with the generative model is to decode the responses, right? So decoding is a probabilistic process, right? So whenever you have seen this process, right? So towards the end, we always go for a softmax, and then after softmax, we get a probability distribution across all the words in the vocabulary. And as a result, whenever you decode or whenever you generate a process response, that is always, it can be unhinged. Unhinged meaning that it's not always guaranteed that you will get a meaningful response. So generative models always do not result in meaningful responses. The responses can be meaningless. It could be of low quality, toxic, false, or hallucination in nature, which is something which is made up. It's not even realistic in nature. A lot of times you have seen this thing happening with these machine learning models nowadays, right? So they make up facts which are not already there. They hallucinate facts and they seem to be very confident in generating, but when you cross check it or cross reference it, there is nothing of that sort which is there in a real world scenario, right? And that is basically as an end result, you basically get something like chain of thought prompting. Right? So we'll cover these individual elements later on. What is RLHF, what is DPO, and all those things. So this is reinforcement learning based human prompting. We'll cover that later on. But for that, we need to learn reinforcement learning as well. But I'll not go to details about what reinforcement learning and all of that is. But we can, to a lot of extent, we can overcome the meaninglessness of a particular prompt with the help of reinforcement learning, wherein we basically take the response and try to see or try to assign a reward to the model for generating a response which is actually good. From good, I do not mean good in terms of quality, but I mean good in terms of everything. Like, so does it match the fact and all those things? And depending on that, the model will decide which translation is the best. So that is basic the reinforcement learning bit added to the machine translation. We already have that integrated in one of the models which is currently out there, right? So the model released by OpenAI that also has reinforcement learning integrated when it is transforming the outputs. But I'll not go into details now. We'll cover that separately later on. The first problem, as we had said, is basically to decode or to generate a response which is probabilistic in nature and hence can be unhinged. Unhinged means that it's not always guaranteed to be meaningful and accurate. The second problem, if you have a very long context or if you have a prompt, it takes longer to compute, right? So if you have a very long context, then the model itself will take time to understand what you are trying to do, right? So if your context becomes longer, the compute time will also become more. The third is, what if we need domain adaptation? I think one of the students did ask this question. That is, your model is trained on a task which is general in nature, right? So you have scrapped data from the web, Wikipedia, but now you want to fine tune that model for a specific domain like healthcare. So to achieve this, then you have to do a supervised fine tuning. That is, you have to pick up data for that domain specifically and fine tune that model for that domain specific task. And last but not the least, deployment in production is a major issue because these large language models are called large for a reason. They have millions and billions of parameters, which make it very difficult for small scale organization to handle and deploy and maintain, right? So make sure that you have enough resources available and the for this, the only way possible around this is to basically make sure that you distill the model. That is, you reduce the complexity of the model, right? So you reduce the runtime of the model, which will, if you have a smaller version of the model or more distilled version of the model, that will be more easier to maintain and work with. You can use specific kernels, or you can create dedicated servers for the model in which the inferencing is only happening, nothing else is happening, right? So you need to have runtimes and hardware which can handle those particular models at scale. So everything to do with production deployment is basically what you can do in order to overcome the challenges faced during the deployment of such large language models.
What exactly is this quadratic attention is quadratic in sequence length? Or what exactly it means?
So if you remember that when I talked about the transformers, the complexity of the transformers when it is trying to predict is big O of n square into d. So the
Yeah.
sequence length is the complexity of the attention. That is when you are trying to generate the output. It's quadratic in sequence length, meaning its complexity is n square in terms of the sequence length, right? So the complexity which was there was big O of n square into d. So it's quadratic in sequence length.
Okay.
So if the sequence size increases, the amount of time which is going to take for generating the output will be square of that, right? So if you're so the more length as the length increases, the amount of prediction time increases with square of it. It's not linear in nature, is what it's trying to say.
And it's linear with respect to the dimension of the embedding
Yes,
sets.
yes. The hidden dimension is linear with respect to that, but the it's quadratic in respect to the sequence length. It has to do with the matrix multiplication which happens internally. So you can go through the multiplication. You will see that the matrix multiplication which happens, the complexity of the matrix multiplication is big O of n square, and because of that, the overall complexity comes out to be big O of n square into d.